Hi, I'm Lytical, and welcome to Beyond Binary, Class 1, my introduction to computer science. And we started at Class 0 because we are computer scientists. If you haven't watched that, go to the description. There's a link there. And while you're down there, leave a like on the video, subscribe, and ring the bell to make sure you don't miss a class ever again. Last class, we looked at binary a little bit. We looked at algorithms a little bit, and we wrote some code using Scratch. In Scratch, we saw loops, functions, conditions, variables, boolean expressions, all of the things that are core to solving problems with code. And that's what this course is all about. Today, we're going to start using JavaScript, a text-based language and one of the most popular programming languages in the world. You can make games with it, you can make websites with it, you can make apps with it, you can make all kinds of things with it. So I think it is a great language to start with. And with most text-based languages, it will look a little funky and will be confusing at first. We're going to see some stuff that looks like this, and this, and this, and this, and this, and it's going to be a little overwhelming. But you're smart. I know you can do it. It's just some text up here. It's just some numbers up here. It's just a few of the weird punctuation keys on your keyboard. And throughout this course, and throughout even just this episode, you're going to be able to understand what these things are doing and how to write it yourself. With Scratch, we could only write code on the official Scratch website using their official editor. With JavaScript, there are tons of different ways we could write it. We could write it directly on our computer in JavaScript files or in HTML files. Or what we're going to do in this course is we can use a web-based JavaScript editor. And these will allow you to write JavaScript code all within your web browser. So you could do it on a tablet if you really wanted to, or you can do it on any kind of computer that supports even just watching this video. The one we're going to use is called Codepen. Feel free to make a free account. It will make things a lot easier for you to save your projects. And from the homepage, we're just going to click on Pen. What's going to be brought up is 3 different sections, one for HTML, one for CSS, and one for JavaScript. And we're just going to use the JavaScript one for this course. So you can slide all the other ones over. The first thing that we did in Scratch was just get an output on the screen. We had an input and we wanted an output. Why don't we take a look at JavaScript's equivalent of when green flag clicked, say, oh honey. And to do that, we would write console.log, parentheses, quotes, oh honey, and then end our line in a semicolon. Already you might be thinking parentheses, quotes, and semicolons. Oh my, what is going on? And I'm going to walk you through it. Don't worry. There's a lot of punctuation in here. There's a lot of weird syntax or way we write code. But over time, like with makeup, like with drag, like with performing, like with any kind of skill, the more you practice it, the more natural it will get for you. We've written this line of code and nothing's happened, but that's because we haven't opened the console. So to open the console, we're going to right-click, click Inspect, and then go right into the console. And here we can see our output is, oh honey. So let's break down this line of code. We've got a function here, like the say function, but instead we have console.log. And this is our first JavaScript function. To call any function in JavaScript, you type the name of the function, and with console.log, we just have a period within the name. Then to call the function or to run the function, we're going to use parentheses. Like we saw in the say block in Scratch, there was a place to put an input, and that's what we'll put inside of these parentheses. So we want to give it the text, oh honey. So if we want to tell console.log that we want it to say, oh honey on the screen, we can just type in, oh honey. But we're going to see a bunch of errors in the console, and we don't have to worry about those for right now. In Scratch, they made it super easy for you to pass whatever text you wanted into the say block. The console.log, that can take numbers, variables, lists, all kinds of different variables. To indicate that this is a text variable, we have to surround it with quotation marks. Everything inside of the quotation marks will get outputted on the screen. And then most lines of JavaScript will end in a semicolon. So to just review it quickly, console.log is the name of a function. We're calling it because we have an opening and closing parentheses right after it. In those parentheses, we have a set of quotes, which surround all the text we want to get outputted. Then the cherry on top of this line of code is just a semicolon. So we want to output more oh honeys, we can just copy it down, add a bunch of Ys. And you might also be thinking, wait, I'm not clicking when green flag clicked. There is no when green flag clicked. What's going on here? Codepen is just running everything inside of this JavaScript file every time you make a change, kind of like an autosave feature. And really across the board, if you're using Codepen or if you're just editing the JavaScript code on your computer, there is no when green flag clicked. It's just your browser or your phone or whatever you're running the JavaScript on, that will tell it to run. And it will just run through the script you've given it. No when green flag clicked necessary. So from here on out, our when green flag clicked block is canceled. You might be looking at this and being like, this is just text and text on the screen in the console. Ugh, there's just like a bunch of red errors. Ugh, I don't want to see all of this. And I couldn't agree more. Let's close out the console by clicking up here. And we'll return to the console maybe in a later episode. It is a great tool for seeing if you have any errors in your code, and it will tell you exactly where that error might be and give you a suggestion on how to fix it. But for now, let's get rid of it, and let's get some more glamorous outputs. So, like at the end of the last episode, I showed that we could make our own functions, like that honey function, where we would just call honey, it would play oh honey however many times we wanted it to play. I went ahead and wrote a bunch of JavaScript functions that you don't need to understand just yet, but we'll call in this class and will make things so much more glamorous and so much easier for you. All we need to do to import them is go to CSS and paste in this URL that's in the description, go to JavaScript, paste in that same URL, and let's turn off the auto updating preview because it's a little easier when we can just click run and it will run our code totally fresh. And to make it easier for you to get started, instead of having to go to settings, copy in the values, and make all those changes, I've created a blank template for you. Then you can just click create pen from this template and name it whatever you want and save it on your account. Instead of boring old console.log, we can use a bunch of fun print statements that I've created. There is print glitter, print rainbow, and if you're feeling a little boring, there is just a regular old print. Now when we hit run, we're gonna see so much more glamorous text. We've got glitter, rainbows, and well, blah. They're all appearing on the same line though, so if you don't like that and want to have things appearing on separate lines, we can just add an ln to the end, and it uses a different function that adds a new line to the end of each print statement. And it is at the end. So with this fourth oh honey, it's still on the same line, so we'd have to add a new line up here too. Let's clear these out by just printing nothing with each of them. If we wanted to call all these functions with oh honey, just like this, we could do that and it would be totally fine. But if we want to change these oh honeys to be oh honey, then we'd have to edit each one, copy and paste it down, and we do not like doing that. It's repetitive, it's annoying, it is boring. It's almost as boring as this regular print function. So instead we could introduce a variable. And to create a variable, we type let, which says let some new variable that we want to have, and then we'll give it a name. We can call this the name oh honey. And to set this variable to something, we'll use an equal sign. And whatever's on the right of this equal sign will be the value of this variable. So here we want it to be oh honey. And this will be a text variable because we've set it equal to this string, in quotes, oh honey. And we'll end this line with a semicolon. Then instead of having all these print functions call oh honey with this new string oh honey, we can just have them use the variable oh honey. And this is why those quotes were needed, because if we didn't have those quotes, then it was looking for the variable oh and then the variable honey. And neither of those existed, so it wouldn't have known what to do at all. Now we can run this again. It's gonna look the same. But if we want to give it all the honey goodness it deserves, we can add a few more Y's. Rerun it, and then it's gonna change for all of them. In Scratch, if we wanted to use a variable, we would go down to the variable blocks, click make new variable. There we call it oh honey. Then we would use the set variable block to set it to a value. Then we would have that rounded block that we could put into that save function, and then update that variable whenever we wanted. Another place we saw variables when we were asking a queen for their name, and then we would be able to welcome them to the stage. JavaScript's equivalent of asking someone a question is window.prompt. And this is a function, so we'll call it with parentheses. Inside these parentheses, you're gonna put some text, and that text will be the question that is asked to the fabulous user of this script. So here we'll say, what's your name? Don't forget the semicolon. Then when we run it, we see this pop-up that says, what's your name? And we could type Anna. So it's asking for our name and then not doing anything with it. I want to be welcomed to the stage. The window.prompt, it gets your name, and then it will output whatever variable or whatever piece of text you gave it. So we can actually just store this in a variable. We can call it let name equals window.prompt. And for now, let's just leave the glittery print. In here, we could type name, which will output that name variable, but we want to say welcome to the stage, whatever your name is. In Scratch, you would use the join operator, which would join two pieces of text. In JavaScript, it's actually so much easier. We just have two pieces of text, and then we use the plus sign to join them. No having to grab extra blocks, drag everything in. So much easier. So let's give this a go. Ladies and gentlemen, please welcome to the stage, Lytical! Wow, 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 wow! And if this font size is a little too small for your welcoming needs, you can use set font size. And this is another one of those functions I'm giving you that is not built into JavaScript, one of the abstractions that I made for you, and we can just pass it a number. And now the welcoming is an appropriate size. Well, maybe a little too big, actually. We could just leave it at the size it was before. So that's how you can add strings. And you might be thinking, add numbers. Set font size 100. Add. Set font size 100. Numbers. Oh my God, are we going to be doing math? And I always think it's so funny that there's this notion that you have to be super good at math to do any kind of coding, because that's so untrue. In fact, coding will handle most of the math for you. Let's take a look at this example I have for you. We have two number variables. There's a 1 and a 6.9. And we don't need the quotes around these because they are just numbers, and JavaScript knows to interpret them as numbers and not as text. So as you can see, if you want to do addition, you use the plus sign. If you want to do subtraction, negative sign, multiplication, star sign, division, slash, it's just going to do the math for you. It's kind of like a gay calculator. Well, at least when we do it. We can also do comparisons with numbers to get boolean expressions, those true or false values. We can see if one number is less than another, greater than another, greater than or equal to another, less than or equal to another, all the combinations. And then what we get back is a true or false value. And if we wanted to get different results, we could actually just change this variable. So instead of this integer being 1, we could set it to 1 million. And if we're updating an existing variable, we don't need to use the let before it. The first results won't change because it's working from top to bottom. Up until line 10, it still thinks that integer is 1. And then when we get to 10, it goes from 1 to 1 million. But actually, now that I think about it, 1 million is going to give us the same results for all of these Boolean expressions. But whatever. Let's say for all my math queens out there that you do want to make this into some kind of gay calculator, we're going to need an input of a number. So why don't we prompt whatever queen is using this for some number? And we can just type in whatever number we want, and we're going to get the math done for us. No calculators. Well, you don't need to be a genius to see that 100 plus 100 is not 100, 100. What is going on here, y'all? Well, my dear child, it's time I told you about the strings and the ints. Window.prompt, that's always going to give you a string. That's always going to give you a value that would be in quotes. So instead of having our integer be 100, it is 100. Suspicious, right? Subtraction, multiplication, and division were kindly able to figure out that we wanted the number 100 and not the text 100. But addition, addition, it always gets ya. In my set of helper functions, I have a function called promptInt, and it will convert whatever text you write into an integer. Integers are only 1, 2, 3, 4, 5, and 6. No decimal places allowed. So we would use a float number for that. And if you wanted to prompt for a float number, you would just do prompt float. Float, please. And there have been a lot of helper functions that we're using in this class, so it might be hard to remember them all, or it might be hard to remember what all the things in JavaScript are. You can always go to Settings, click JavaScript, and go to the link you have in there. And here are all of the helper functions I've provided that I've custom written for this class. And it's also great for you to see what's actually happening under hood and understand these abstractions that I've made. We're defining the function, and in a little bit, I'll show you how to define your own functions. Above each function definition, I have a comment that explains what the function is doing. And this is a line of code that will explain what parts of your code are doing, so another person who's using your code, using your abstractions, will understand it more easily. And to write comments in JavaScript, you just start a line with a // and anything after that will not be run. So we can scroll down and we find the promptInt and promptFloat commands. And all you need to know about these functions is that they're going to keep asking you for an integer until you give it one. If we look inside actually though, we can see it's calling that same window prompt command, but then it's passing that value into another function called parseInt, which will check if it's an integer and if it is, convert it into one. And we're using a while loop here, which is similar to a forever block in Scratch. So until we get that value to be some kind of integer, then it's going to keep asking us over and over again. And the same thing is true for this prompt float function. So now we can rerun this with these functions that we know. So it says, give me a number, I can put high in, and it'll keep asking this until we actually give it a number, so I'll give it 20 this time. Then for a floating number, we could put 20 in there again, or we could put an integer in there because all integers are also floating numbers. But why don't we put some decimal value in there instead? Click OK. And now we've created a gay calculator. You're welcome. My second grade teacher is shook. All right, enough of these numbers for now. Let's go back to some of the text. Instead of just comparing numbers, checking if they're greater than or equal to or whatever, could we compare letters? So instead of seeing if 1 is greater than 0, we could say, is yes equal to yes? We can't just use one equal sign here. We can't just use two equal sign. We need to use three equals signs here, because otherwise it would think we're trying to maybe create a variable yes, if that's a string or something like that, and set it to the variable yes, which is not what we're going to do. One equal sign is for setting a variable. Three equal sign is for checking if they are the same. Throw the semicolon on and click run. And we didn't even need to run this to know that this was going to be false. One of the next things we saw in Scratch were conditions. If something is true, then do something else. And that if block was shaped like a C, we could stick lots of other functions inside of it. And in JavaScript, it's kind of the same. It's going to look like this. We write if, then we have parentheses, which are going to contain the boolean expression, something that's going to return true or false. Then kind of like that C shape, we use curly braces to indicate what we want to do if that condition is true. There's an opening one up here and a closing one down here. Now we can kind of create a little quiz here. You gay, bruh? Why? Yes, work, bitch! But we should probably handle the case when someone answers no. In Scratch, we'd have to go grab the else block, switch out our condition, switch it all in. It was actually kind of a pain. In JavaScript, we can just write else right after this closing curly brace, and then add a new set of opening and closing curly braces. Here we can just print meh. So if we run it again, answer anything but Y, we're going to get a meh. But what if I'm very enthusiastic and want to say yes with a capital Y? Meh? But bruh, I am gay, I swear. In this if statement, we should check two conditions. If the value we get from this prompt gay, is it lowercase y or is it uppercase y? To create an or Boolean expression, we use the, what is this? We use the pipe, or it's like the straight line command. Ironically, we're going to use the straight line key. And this is going to be over the enter or return key, and you're going to hold shift to get it. We're going to use two of these. So we've got our first expression. So if gay equals lowercase y, or, and this is the or, gay equals uppercase y. Now when we enthusiastically answer this question, yes, work, bitch. Work, bitch. Work, bitch. Yes, work, bitch. This is how we can compare text and also create an or Boolean expression. But if we want to create an and Boolean expression, so check if the value is this and it's that. And it makes a little bit more sense with numbers, actually. Here we have a few if statements where we're checking a number. We ask some potential trade how far away they are. If their distance is under 300, we'll print something. If it is between 300 and 5,000, so we're using the ampersand and we're going to use two of them, just like we did with or, it will confirm they are between this distance, and then otherwise we'll reply with another value. And how close is this trade? Maybe 2,800 feet. Does that work? What happened? No. I think my browser is a little mad at me that I keep having all these pop-ups coming. I know Google Chrome will try to suppress them so you don't get browsers giving you 1,000 different pop-ups when the page loads. So if you run into this problem, just try giving the page a refresh and it should work fine. How many feet away are you? Now let's say 2,800, maybe let's say 2,500, maybe we've gotten a little closer. And it's walkable. We've seen how to call functions, we've seen how to create variables, number variables, text variables, we've seen how to compare them all. But there are two more things that we did in Scratch still that we haven't seen how to do in JavaScript yet. The next thing we're going to see is loops. And this is what we would use our repeat block for. If we wanted to print oh honey 10 times, instead of copying and pasting it, we would just say repeat 10 times. To do something a set amount of times, we'll use a for loop. And a for loop, just starting out, we're going to write for, and then the rest of it will look kind of like an if statement. We've got the parentheses, we've got the curly braces, and then inside of the curly braces is where we'll put the function we want to run. Then in here, in the parentheses, is where it gets a little tricky. And I think this is one of the most tricky things to get when you're first learning to code. What goes inside of this for loop? But don't worry, you can always copy and paste it in. You can always Google, how do I write a for loop in JavaScript? Copy and paste it into your code, and you shouldn't feel like you have to memorize this. There are no tests in this class, so why would you want to go and memorize this if Google is just, well, right up there? The first thing we want to do is create a variable to keep track of which iteration or which time we're going through the loop. So to do that, we'll create a new number variable and we'll start it at 0. And typically with a for loop, this will be called I. So we'll say let I equal 0, and with a semicolon. Then the next part is how many times you want to run the loop. We'll give it a condition or a Boolean expression. We'll say while I is less than some number. Here we can say while I is less than 10. So when I is 0, 1, 2, 3, 4, all the way up to 9. And to increase I, the last part of this is we'll say I equals I plus 1. And this will just take I at 0 and add 1 to it every time. There is a shorthand for this. Instead of having to just do I equals I plus 1, you could instead say I plus equals 1, which will increase I by a certain amount. If we wanted to go up by 2, we could do it like that, or 5, we could go like that if we want to count by different numbers. But most commonly, we'll be going up just by 1. And if we're only going up by 1, we'd use even a shorter shorthand of just I plus plus. So now when we run it, we get 10 honeys. And if we want 1,000, why do we make this a little bit smaller so we'll be able to see them all? We can easily see all of our honeys. They're all on the left side of the screen right now, so if we wanted to print out more in each row, we could put a for loop inside of this and say for. Actually, let's just copy it down. As I said, this isn't something you need to memorize. It's easiest if you just copy it down for the moment, and eventually it will start to become second nature to you what's going to go in there. You can either copy it down or type it out. Well, typing it out will probably help you learn it faster, even if you have it side by side. And since we have a loop nested inside of another loop, we actually can't use the same variable here. We can't use I again, because otherwise both of the I's are going to get confused. Instead, we could just call this one J. And if we had another loop in here, we could call it K. And another in there, we could call it LMNOPQRSTUV, whatever. The alphabet. I know it too. And then instead of printing a new line for all of these honeys, we only want to print it on the last one. So we can do a check. If J equals 999, so for the last one in this iteration, then we'll print it on a new line. We'll go and run this. Oh my God. I think my computer is gonna break. Oh my God. Okay, let me change some of these numbers. A little too big for my computer to handle. This is 10 by 10. Oh, and we also have to change J to be while it's equal to 9 instead of 10. My computer is literally shaking. So that's what you're gonna need to know about loops. The final thing with JavaScript that we saw with Scratch was how to create our own functions. So if we wanted to throw this all into those beyond binary helper functions just to have a function that would give us a wall of honeys, we would define our own function. And to do that, we type function. And this is kind of like let for variables, but instead it's function for functions. Duh. We call this honey. Then we'll have parens and curly braces. Throw all this in there. And since the indentation got a little weird, we can go in to this dropdown and click tidy.js. Just to make it all clean again. You might notice we've had lots of different tabs and indentations. They are just for you and for me, or whoever is reading the code to understand it better, but they don't actually affect how the code is working, at least in JavaScript. So they're just there to make your code look snatched. But they are not necessary for your code to actually run. Now we can call honey if we want to by typing the name honey, then calling it with parentheses. But we don't want to get 10 by 10 every time. We want to be able to pass it maybe how many rows and how many columns we want. So maybe we want 100 by 100. We'd want it to accept these two numbers and use them instead of the 10 by 10 here. So in our function definition, in the parentheses, we can define parameters. So here we would call that first parameter rows, and the second would be calls. And we would just separate them with a comma. These are just like print commands or the console.log command. They accept a parameter of a text. This will accept a parameter of 2 numbers. And instead of 10 here, we would use rows. And here we'd use calls. And here, this is actually a lot easier. If we change the number, we'd use calls minus 1. Now we run it, and we can bask in all the honey goodness. That is all I had to show you today. We saw variables, functions, conditions, loops, prompting, getting inputs, so many different of the puzzle pieces that we saw in Scratch. Now you know how to do them in JavaScript. But I don't want you to just know how to do them. I want you to do them. You aren't going to learn how to code if you aren't coding. At home, I've got a few things for you that will get you started to type in CodePen, writing code, running your first JavaScript program, so you have a guiding point. And feel free to make any sort of variations on these that you see fit. The first thing I want you to do is just go write your own welcome to the stage script. You're going to use a variable for this. You're going to prompt the user for this, and you're going to call the print function. Taking those first steps, opening CodePen, writing the code, importing the necessary files, and making sure it all can run, that's the first step to programming. Even if it's simple, even if it's small, just the first step of writing the code will start you on the path of being a programmer and being a computer scientist. The next thing I want you to do is make a little game, and it is a guessing game. The person who's playing this game is going to have to guess how close they are to you. You'll have a variable that stores your distance, and then the program will keep asking the player how close you are, and it will give you a hint. If you guess too high, it will tell you to guess lower, and if you guess too low, it should tell you to guess higher. So we put in 100, it will say too small, try again. If we put in 400, it will say too big, try again. And if we guess just right, then it should print a message on the screen saying we guessed correctly. You're going to need to use some conditions in this. You're probably going to need to use some kind of loop, maybe a while loop, maybe a for loop. And the last thing I want you to do is print out a suite of background dancers. You're going to prompt the user for a number of dancers or a number of rows of dancers. And we're going to print the dancers in formation. So if you have one row, it'll just print out one dancer. If you have 4 rows, it will print out 4 rows of dancers. And the first row will have 1 dancer. The second will have 2 dancers. The third will have 3 dancers, and so on. And if you're feeling basic, you could have them all aligned to the right. But if you want a more challenging task, try aligning them all to the left. Or try aligning them in any sort of pattern that you are interested in doing. In the description, I'll have information about all the at-home coding I'd love you to do, and a few hints if you get stuck. As always, you can leave a comment with any questions. You could tweet at me at @theanalytical with any questions as well. And when you're done with your final products, go ahead and share them. Use hashtag #CodingQueen to let everyone know that you are a coding queen too. That's all for this episode. If you loved this episode, leave a like on the video, tell your friends about it, subscribe, ring the bell, make a new account, subscribe again, ring the bell again. Thanks so much for watching. Bye, everybody.